Hi, everybody. That was an excellent talk. I only caught the end of it, but I will be watching the live stream later. So a tough one to follow, but today, yeah, I'm pretty excited to talk to you about a project that we've been building to try to create a better home for metadata on Web3. It's called Tableland. You can find it at tableland.xyz. So I'm going to just spend a couple slides here telling you what that is, so then you know why I tell you the rest of this story. So Tableland is just tables. We thought this is really interesting because Web3 actually lacks this data structure in any sort of consistent, reusable, composable way. When I say tables, I just mean rows and columns in Web3 that you can query with SQL. It's an interesting feature that you can add when you have structured data in tables. We're building it so it'll be interoperable with all of the protocols that do excellent things on top of data. And we brought this week an early beta. It's a gateway that you can actually explore what it means to use basic SQL and tables to build projects. And so these tables this week are anchored to Rinkeby. So these are actually, every table is an NFT, so you can actually trade access to that table. You can burn access to that table. And we're experimenting with a lot of things right now. So if you're a developer, we'd love to get you in there, giving us feedback on what this thing looks and feels like. We're very early in this project, so this is this week, but we're going to be moving pretty quickly to defining the protocol and the network, and then launching the network on mainnet as quick as we can. So yeah, today I wanted to talk a little bit more about metadata because I think it's a really interesting problem right now in the way people are designing projects in Web3, but it's also a really cool opportunity to kind of take these projects to the next sort of phase of development and the next sort of building the next applications and possibilities in Web3. And so I'll talk about that. I'm going to talk about these trade-offs and limitations that we've been identifying, and then talk a little bit about Tableland at the end and show you what I mean when I talk about having tables in Web3. A little bit about me. My name is Andrew. I'm the co-founder of a company called Textile. We've been building for a number of years in this space, really focused on IPFS and then Filecoin, and actually building some early bridges in Ethereum, and just building a lot of little side projects, experimenting what's possible here. But we've been thinking a lot about data. Data is really in our wheelhouse, and we've been really talking to a lot of developers about what these pain points are and what they're trying to build and where they're getting hung up building things on Web3. And this is where Tableland really emerged. It's just identifying this big hole. And one thing I didn't say about Tableland that I think is really an interesting insight here is we don't talk about it as a database, because if you think about any project that's been built for Web3 that's a database, it's actually pretty redundant most of the time, because as you know, the layer 1, Ethereum, is actually a pretty awesome database for a lot of things. And so if you can think theoretically about breaking up the way you think about a database as two parts, you have sort of the data, the structured data, oftentimes in tables or documents, and then you have the methods of interacting with those tables. And then you have all the other stuff, which is your access control, your role management, your collections, things like that. All that stuff is actually what layer 1s are awesome for. And so we've been building just the tables and making them so that they work with the layer 1s. So I wanted to back up and explain some of the thinking for why this is important and interesting to 2018. And if any of you were here in 2018, so were we, and we were building things with other experiments that we were creating at the time. And I don't know if you recall how much people talked about dApps. I mean, we still talk about dApps quite a bit, but dApps were a pretty common topic back then. And what was really interesting thinking back on this moment was actually how basic the idea of dApps was in 2018. It was literally, let's take Web 2 apps and now make them decentralized. And we saw a lot of projects building this way and trying to basically say that would be what Web 3 would become, which is a fine starting point, and it created a lot of, again, really interesting experiments. A lot of projects have actually moved out of this and pivoted into interesting products in Web 3, but really this didn't come to fruition. And I know I'm preaching to the choir saying something different happened. And so, everybody was thinking at the time, yeah, apps, but decentralized now. And then last year before-ish, something totally new came, right? Which is all of this wave of momentum around NFTs. And for me, I think there's a really linear connection here that I haven't heard many people articulating. And so, yeah, so NFTs everywhere, right? And actually, I think NFTs as sort of the keys sort of your access control, your membership in Web3, so you can kind of bleed into DAOs as well. But sort of the NFT, I think, domain is really worth focusing on here. But I think that actually NFTs, and if you look at NFTs and DAOs, we can think of them not as necessarily just tokens and just concepts in Web3, but we can actually think of them as the new application stack. And so what we thought was that apps were going to be just like they were on Web 2, but now decentralized. And what we're seeing is that the app now is not a UI, it's actually a human experience. And so people are buying NFTs now not for access to a UI, but they're buying them for the experiences they confer. And so those experiences could be membership, they could be roles in a Discord, they could be alpha, they could be access to future NFTs, they could be just the ability to flip them. These are all games. These are all applications if you really think about it. And so for me, thinking about why dApps didn't happen, I think this is why. Web3 got something totally new that humanity hasn't really experienced before. And I think everybody here is aware of that, but I think this framing of it really explains what's going on in my mind, thinking about what applications are really being built. And these are the applications. And what's really cool about these applications is that they're totally driven by metadata. So metadata for Web3 can be built in a few different ways, but that metadata does everything. It describes what the assets are that make up the artwork in your PFP. The metadata tells you what channels you're going to get into in the Discord. The metadata tells you your score in a game. It tells you what it's your decision of what NFTs you're going to display in your gallery. This is all metadata that we're trying to build and create and connect to Web3, and it's fairly scattered. So a really basic example of this is the most obvious one, which is kind of the PFP or artwork or any sort of asset-based NFT. The first thing that happens is to display that NFT, it's going to have to get metadata. And so there's a few different ways to do this, but I'll show you the kind of out of smart contract way. Here is, you go to LooksRare, OpenSea, and they're going to call the token URI for the token that you're looking at. And so you're going to, so you have token 0, they're going to call the smart contract read method on token URI for token 0, and it's going to return a token URI, which is that URL for getting the metadata for that token someplace out of the smart contract. So oftentimes this is for an IPFS gateway, sometimes it's for an S3 bucket, it can be whatever it is. Actually, I've never heard anybody look at this either, but outside of DeFi, I feel like token URI might be the most accessed read method in Ethereum. It'd be an interesting thing to figure out. But so it returns this metadata. You can see it's structured data in JSON that then tells the gallery or the marketplace or your wallet what to display, the name of your asset, the images behind it, where to get those, all of that. But so the way that creatives are storing and making this metadata available has trade-offs. So the first option is often the best option for a purist, which is to put all of that metadata directly into the smart contract. So a great and really famous example of this is Loot. And so that's the whole idea of Loot, is essentially it's really basic information stored purely on chain, and then you build out from there. And this works great for some projects, but it can be really limited and costly, right? Because actually putting raw data on chain is costly. So if you're doing artwork or you're doing, you have big imagery, things like that, or even if you have complex metadata that you want to create a lot of information around this token, it's going to be very costly. And then mutating that data can also be costly because every mutation is going to be a full write back to the state of that smart contract. And composability is going to be really high, right? Because it's all right there on chain. You can build other smart contracts to reference it. You can do lots of cool things. But by far the more popular option for many of the most famous NFT projects is actually just to push it off to decentralized storage. So the way this works is you actually create those metadata payloads as static files, and then you put them on IPFS. You go to Infura or Pinata, and you have them pin that file for you, and then you get that token URI. Well, this actually introduces more problems. It's great for scaling because it's pretty cheap, but it makes mutability not only costly now, but complex. And so it's costly because every time that you want to change that IPFS payload, you're going to have to change the pointer on chain. So there's going to be a call to change the state. And now it's actually really complex because of the way that you're storing that file right now. If the user is doing the change, how are you going to get them to get somebody to host it for them? How are you going to get them to make sure that it's available, the new change is available someplace on the decentralized storage network? And then composability is going to be pretty low because of those same two problems. And then, of course, there's a lot of projects that use centralized storage, and this obviously could scale as much as you want, like Web 2 style, but composability is going to go to junk because nobody else can use it, and the users don't really own it, and there's all sorts of all the problems that you're aware of if they do it this way. But there are NFTs that do it this way. So with these trade-offs for a creative thinking this through, what they're going to do, they making that decision means that they're actually changing the way that they're building NFTs and the experiences around them. It means that they're limiting what the application is that they can actually build with these things. So if it's stored in static files, for example, it really limits the experiences you can build because mutability is going to be really hard, ownership is going to be really hard, those things. But in fact, metadata is such a powerful construct because you can see it it starts with the token URI, but it flourishes into everything like I was mentioning before, your roles in your DAO, your membership in Discord, your assets that you acquire in your game, the new, whatever it is. And so with the metadata, we should be actually building unique experiences that are interoperable across any game that people build, new interfaces that people bring, and in user-controlled worlds, so on and so on. And so this is our goal in Tableland. This is why we're building Tableland. It's just tables for this metadata, where we focus on the tables themselves being mutable. We focus on the tables themselves having sort of interoperating with the layer 1 so that you can change ownership of those tables to your users. And actually, with SQL, it's really cool because you can mix data across tables, which means you can have a table that's immutable and query it combined with a table that has mutability. So that in a way, limiting some of your data to being immutable while making other data mutable. And so just some basic examples of what you can do with this. You can build NFTs where the user can actually change that NFT appearance on the fly based on what they're doing in your game. A really basic example that I've been giving a lot this week is with loot. The first thing that, if you imagine loot, it's just a set of the things that you own in the yet to be built game. But if you imagine the next thing that any game builder wants to do is they want to create an inventory where your player can see the things that you own, whether it's in one loot or multiple loots. And then with that inventory, you want to give the user interactivity so they can choose which items in their inventory are going to go with them on the current adventure. So a concrete example of that, maybe in your loot you have a broadsword. That broadsword in this game is going to make you more powerful. You're going to have a power score of 5, but you're going to get slower because you're carrying a big hunk of metal. So that could be stored in a table. The user's inventory could be stored in a table where the user could choose whether their sword is enabled or not. Those basic capabilities are just metadata and different rules for who can change them. And actually that loot example, we have an example in our docs doing it on synthetic loot, if you're familiar with that. So you can play with that already. Very basic, but just give you that idea. And so our idea here is Tableland is actually a network of validators that are maintaining these tables so they'll be permissionless. And our goal is to make it fairly cheap, highly mutable, and highly composable. And the reason it's highly composable compared to data stored purely on-chain is that have you ever tried to fork a data set that's in a key value store in a smart contract? It's actually very limiting and hard to do, but storing it in a fairly readable table on a network that makes it easy to extract that data for any new user, you can fork a table, you can build on an existing table. So your view of a game built on loot, I can fork and build my game built on loot in a really easy way, just with metadata. So I want to show you, we have this little terminal in our on our homepage, so you can actually play with this. Right now you have to get whitelisted with your wallet address in our Discord, so just a flag there. But once you do that, I'll just go through the steps here. I'm going to use this terminal to create a table, and then I'm going to insert a row in the table, and then I'm going to query the table. And you'll see, if you've ever used SQL before, this is what it's like. Right now it's on Rinkeby, so that's what I just connected to. Has a bunch of commands these are just terminal-based commands that are wrapping up our little JavaScript client. You can see that's how you select. So first thing I'm going to do is I'm going to create a table. The really cool thing about tables too is like you can actually read the schema of the table. And so here we have this idea that tables can be compliant with known metadata. So here's an ERC 721 table. And so we know by making this, it's going to comply with all the necessary attributes of a ERC 721 NFT. And this will be really handy here in a second. So I created it. There it is. It took a second to basically register that on chain. And here I'll just do a select statement, and you'll see it's empty. But it will share with me the schema. So there are all the columns that were created, but no rows yet. And we were just talking last night, we need to actually make this a table-based response. So you can see that it's table. Right now, it's just showing the JSON. So here I'm going to insert a row. That 0 at the top, the first item I'm going to insert there, that essentially could map to a token ID in your smart contract. And in that way, in your smart contract, when you're calling that token URI method, it's just a templated URI that you know where to call in Tableland to get this exact row with this exact metadata. Okay, I inserted that data. I'll just do another select here, and you can see now it has that data. Now what's really cool is on the gateway, because this is an ERC 721 table, I can select against this table and that row ID, and using this format, which is really common in that token URI method of basically templating your URI response from your smart contract, I can use that here, and I'll just show you against our gateway making that query. So I think I'm just copying and pasting the fields that I needed. Yeah, so here I'm just going to swap in the table ID, which came back from the create statement. It's just a number 135, and then the ID of that row, which is 0, like I was pointing out. And you'll see it spits back JSON. Just this is exactly what OpenSea or LooksRare or anybody who displays tokens expects. And you can see Tableland isn't for storing big data or big blobs of data. So here I'm still leveraging IPFS for storing the imagery, the static attributes. This is really just the metadata that wraps it all up. If you're interested in all that, we have some really cool use cases on our docs. We have some really awesome grants for the hackathon. So if you want to play with this, we're really hoping to see some cool stuff built already this week. But we'll be here all this week. Yeah, and in the docs there's this loot, the synthetic loot example where you can actually play with an inventory based on the loot you have. And like I said, we're really early in our roadmap, so we'd love to get you involved, be part of this, and help us define this new metadata layer for Web3. Join us on Discord if you want. There's a little QR code. I'll have it on the next slide too. Just repeating there, we have some grants and bounties available. And yeah, check us out. Thank you.
Awesome. Thank you so much.
The QR? It's there, yeah.